Our team at the Utah Geospatial Resource Center is excited to introduce the new UGRC API Client. This desktop program lets anyone use our spatial API to add XY locations to a table of Utah addresses for free. Simply drag and drop your table into the API client, select your address fields, and click Go. The client taps into our authoritative statewide address points and roads to determine the location of each address. These datasets are updated constantly by cities and counties and then pulled together by our data team. You'll not find a more authoritative set of Utah-specific data anywhere else. Thank you to all our local partners that make this possible. You don't need any complicated GIS software or expensive licenses to use the client. You'll simply create an API key and then you're off to the races. You can run it on either Windows or Mac OS. To get started, download the latest version of the API client from github.com/agrc/api-client/releases. If you're on Windows, select the Win32 link. Run the downloaded .exe file and follow the on-screen instructions to install the client. If you're on a Mac, select the .dmg link. Double-click the downloaded file to mount the image and then drag the program into your Applications folder. The first time you run the API client, you'll be asked to create an API key. This authenticates your installation with our API and allows us to monitor usage levels on the server. To do this, first click on the link to go to the Developer Console. If you don't have an account already, create one by choosing a username and password. After a minute or two, you'll receive an email confirming your new account. Just click on the link in the email and it will take you to your console overview page. From the overview page, click on Manage My API Keys to go to the Key Management page. Click on the Generate Key button to generate a new key. You'll create a Browser Applications key and set the URL pattern to api-client.ugrc.utah.gov. Go ahead and leave the key use status set to production. Once you're finished, it'll drop you back to the Key Management page. Now that you've got your API key, highlight it and copy it. It will start with AGRC and have a bunch of numbers after that. Switch back to the API client and paste it into the API key box. The client will make sure it's valid and give you a thumbs up if everything looks good. Go ahead and hit Next to start entering your data. Now, the next time you open the client, it'll skip this step entirely and take you straight to geocoding. Getting good results out of the API client depends on having good input data. The client needs two separate pieces of info for each row, a street address and a zone. These need to be stored as two separate columns within a CSV file, so you may need to separate your addresses out before using the client. Be sure your file has a header row with the appropriate column names. Any spreadsheet program like Excel or Google Sheets can save to CSV. The street address should be a single column in the form house number, street direction prefix, street name, and street direction or suffix. While some addresses can get away without a street prefix or suffix, you'll get better results if you've got them for all your addresses. The zone field must be a separate column in your data. You can use either the city name or the zip code for the zone. If you choose to use the city name, the API will do its best to match the names to a location. However, it's possible that it won't be able to find a good match for a city name. This can be caused by misspellings, differing abbreviations, informal names, or old names for recently incorporated areas. If your data has zip codes, using those for the zone field instead can solve a lot of these problems. This can result in both a higher overall match rate and also more accurate individual matches. Once you've got your data formatted and separated into these two fields, you're ready to geocode. You can either drag your CSV file into the API client, or you can click on the Choose File button to browse your file system. The API client will read your header row and list the columns it's identified in your file. It will also try to guess which one should match the street address and the zone fields. You can change these with the drop-down menus under Assign Fields. The client will remember what fields you've used in the past, so if you're geocoding a bunch of similar files, it should automatically choose the right fields for you. You can see a sample of the data chosen for geocoding at the bottom of the screen to verify you're using the right fields. Once everything looks good, hit Next. The geocoding process returns X and Y coordinates for each address. We normally think of these as longitude and latitude, but the API can return coordinates in any spatial reference system. The API client presents three common reference systems to choose from, or you can specify any other system using its well-known ID number or its WKID. This is also often referred to as an EPSG code. UTM Zone 12 North is the state standard for GIS data. The XY coordinates are in meters east and meters north of the UTM 12N origin point. WGS 84 is what you'll choose if you just want straight up longitude and latitude in decimal degrees. This is probably the most widely supported and understood format outside of the GIS world. If you're going to be using the geocoded data in a web map, you can choose Web Mercator. These coordinates are also given as distances in meters from an origin point. Now that you've chosen a spatial reference, the API client will give you an estimate of how long it thinks it will take to geocode your table. This is based on a rough baseline of about 3 addresses per second. The actual speed will depend on your connection to our server and the server's current load. As it processes the table, it will update this estimate in real time, along with telling you where it's at and how many address matches it's finding. Just sit back, relax, and enjoy the show. If you have a rather large table of addresses, we recommend that you test a small sample of them first. This lets you verify that the output works for whatever it is you need it for, without wasting time geocoding the whole shebang. Once it's finished geocoding, the API client will report the final statistics and ask you to save the file. The output table adds a couple of columns to your input data. These include the XY coordinates in your chosen spatial reference, the match score, and the address that it matched to. If the API client can't find a match that scores greater than 70, it considers an address unmatchable and returns a score of 0, with the other fields being left blank. A score of 100 usually means one of two things. First, it could have found a perfect match in our statewide address point dataset, or secondly, it could fit perfectly in a range of addresses along a street segment. A score of less than 100, but still relatively high, can mean that the API was able to place the address along a street segment, but something was just slightly off, like a missing street suffix or minor misspelling. Finally, a lower but non-zero score usually means the API found a similarly named street somewhere and your address fit in its range of address numbers, but it's not a perfect match. You'll want to review these. Sometimes, the address and its match will have mixed up street directions. Adding location to your data opens it to a whole new world of insights and analysis, and the new UGRC API client makes it easy for anyone to do this. We hope it helps you gain new insights and explore new opportunities with your existing data. Our crack team of developers is constantly improving the client. This video was produced on version 1.5.2. Your client will update automatically as new features are released. Please reach out to us if you have any questions. If you run into any bugs or have any suggestions on how to make it better, feel free to open an issue at github.com/agrc/API-client. We will look into things and make any fixes that are needed. Have a great day!